Organic chemistry isomers are molecules that have the same chemical formula but different structures. Isomers can have very different physical and chemical properties, even though they have the same atoms and number of atoms. In this article, we will provide an overview of organic chemistry isomers and discuss some of their properties and applications. Isomers can be classified into two main categories: constitutional isomers and stereoisomers. Constitutional isomers have different connectivity of atoms, while stereoisomers have the same connectivity of atoms but different spatial arrangement. Constitutional isomers are molecules that have the same molecular formula but different arrangements of atoms. For example, butane and isobutane are constitutional isomers. Butane has a straight chain of 4 carbon atoms, while isobutane has a branched chain of 3 carbon atoms and a methyl group. Other examples of constitutional isomers include pentane and neopentane, and ethanol and dimethyl ether. Stereoisomers are molecules that have the same molecular formula and the same connectivity of atoms but different spatial arrangements. Stereoisomers can be further classified into two subcategories: enantiomers and diastereomers. Enantiomers are mirror images of each other, while diastereomers are not mirror images of each other. Enantiomers are molecules that are non-superimposable mirror images of each other. Enantiomers have identical physical properties, such as boiling point, density, and refractive index, but they differ in their biological activity and optical rotation. One example of enantiomers is limonene, which is found in the oil of oranges and lemons. Limonene has two enantiomers, R, limonene, and S, limonene. Diastereomers are stereoisomers that are not mirror images of each other. Diastereomers have different physical and chemical properties, such as boiling point, density, and reactivity. One example of diastereomers is the amino acid isoleucine, which has two stereoisomers, L-isoleucine and D-isoleucine. Organic chemistry isomers have important applications in various fields, including pharmaceuticals, materials science, and agriculture. For example, enantiomers of drugs can have different pharmacological properties, with one enantiomer being more effective or causing fewer side effects than the other. This has led to the development of chiral drugs, which are drugs that contain only one enantiomer. Isomers also have important applications in materials science. For example, the properties of polymers can be controlled by the arrangement of the monomer units. Isomers can also be used to tune the properties of organic semiconductors, which are materials that have electronic properties between those of metals and insulators. The spatial arrangement of the molecules in organic semiconductors can affect their electronic properties, such as charge mobility and photovoltaic efficiency. Constitutional isomers are molecules that have the same molecular formula but different arrangements of atoms. This means that constitutional isomers have the same number of atoms of each element but differ in the way that these atoms are bonded to one another. This leads to different chemical and physical properties of the isomers, even though they have the same molecular formula. One example of constitutional isomers is butane and isobutane. Butane has a straight chain of 4 carbon atoms, while isobutane has a branched chain of 3 carbon atoms and a methyl group. The structural difference between butane and isobutane